Greetings, students. This is Saxon Algebra 2, Lesson 98. The title of this lesson doesn't make any sense to me, but that's okay. Relationships of numbers. I don't even know what that means. But they're fun little problems that I think you'll enjoy once you get the hang of them. Okay, we're going to start with one that's super easy. And this is also a lesson where I don't like the diagrams that John has drawn. I skip them or draw them slightly differently. If you look in the book, you'll see kooky pictures. I'm not doing that. All right, find the number. I'm going to write it out so you can see it. Find the number that is 7/10 of the way from 30 to 40. Okay, we're going to visualize this on a number line. Okay, but unlike most number lines, we're going to jump in here at 30. And there's 40. Notice I put 10 hash marks after 30. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Okay? Now, we're supposed to find the number that is 7/10 of the way from 30 to 40. Now, this is an easy one because there are 10 spaces, there are 10 numbers from between 30 to 40, and we would need to find 7 of the 10. So because this number is 10, and it's 10 between 30 and 40 anyway, it's super easy to calculate this, right? 1, 2, 3, 4, 5, 6, 7. This number is 7/10 of the way, right? 8, 9, 10. There's the 10 jumps. This is 7 of them, and we know this number would be 37. Okay? Now, this one's easy to figure out, but we don't want to count on every problem having a denominator of 10 and being 10 spaces in between the two numbers because that's just not likely to happen, all right? So what we need is a cute little formula to solve this. So what it's going to be is we're going to take the smaller number and add to it. S stands for smaller, I'll just write small. L stands for large, I'll write that, makes more sense. And F is the fraction. So let's use this formula on this problem and see if we can figure it out. So let's just bucket. Smaller number in this case is 30. The fraction is 7/10. Sorry, that's a little small. The larger number is 40. The smaller number is 30. Okay, so we used this formula. I'll puffy cloud of knowledge it after I finish writing this so that you can still read it while I'm working. So let's fix this. 30 plus this difference, because there are no variables in here, we don't have to distribute. We can actually solve this. This is 10. So 30 plus 7/10 times 10. These cancel. We get 30 plus 7 equals 37. And that's the same answer we got using the graph. So this formula, forget those numbers, this formula will allow us to solve these kinds of problems even when the numbers are not so picture perfect. All right? So let's do 2 more problems like this using our formula. Okay, and I'm going to write it again up here. We take the smaller number and we add the fraction times the difference of the numbers. Smaller, fraction, larger, smaller. Okay, so this time instead of writing out the whole problem, I'm going to do what I recommend you do. just make one of our classic little charts over here on the side. I write the variables in the order I'm going to use them in the formula. All right, find the number that is 1/5 of the way, okay, that's the fraction, 1/5 of the way from 1/8 to 9/11. John will always give us the fractions with the smaller and then the larger, so you can count on that. Okay, so now we're going to use our formula. 1/8 plus 1/5 times 9/11 minus 1/8. I was bold and I didn't use brackets here, or buckets here, because there are no negatives in any of our numbers, so I felt comfortable doing that. Okay. So you can see that what's annoying about these problems is not the complexity of the formula, simply managing all these fractions, all right? So here's my rule of thumb. Only fix what you need to fix. So I'm not going to worry about this one or this one. I'm just going to focus here because this is where I want to start. I want to actually do this subtraction so I can multiply by 1/5. All right, least common denominator between those monkeys is 88. Nothing pretty about that. So this one will do 8 over 8, and this one will do 11 over 11. So just the parentheses now are going to be 72 over 88 minus 11 over 88. Make sense? We adjusted both of these to get 88 and multiplied the top by the same thing. Okay, that was a lot. Now we'll subtract, and we get 61 over 88. And we multiply that. I'm copying down the rest of the problem now. I just skipped it there because I was just working on the part in the parentheses. Now that's simplified. Now I want to multiply. Okay, 1 over 8 plus, okay, the top's going to be 61. The bottom is going to be 88. And let's just do that. It's 440, but let's prove it. 0, 4, 44. There it is. Okay, wow. That's a really big denominator, isn't it? But that's correct. So now we have to make this match to that, and I can see by my numbers here that this is 8 times 11, and this is 5. So this equals 8 times 11 times 5, right? I'm looking to see what I have to multiply this by to get 440. And if 440 is made up of 8 times 11 times 5, then I need to multiply my top and bottom by 55. Does that make sense? That's how I knew how to adjust 8 to get 440, was I saw the components that I multiplied up to get 440, so I used those as clues to see how to fix this. Okay, so now I have 55 over 440 plus 61 over 440 equals 116 over 440. Okay? That's correct so far, but we still can reduce this. What jumps into my mind when I see the 16 and the 44, I think both of these are divisible by 4. So let's divide by 4 over 4. 4 goes into 100 25 times, and 4 goes into 16 4 times. So that tells me this must be 29. Right? 4 times 25 equals 100. 4 times 4 equals 16. 100 plus what, 16? 116. This one's easier. 4 into 440 is 110. This is our final answer. 29 is prime. So we're done. Yay, that's the right answer. Example 98.2. Okay, so what I hope this example proved to you is that the formula isn't the hard part. Up isn't the hard part. Managing all these wicked fractions is where it gets to be a little bit of a headache. But I'll tell you what, it's been a while since we did any rigorous fraction work, at least as far as I can remember. So this is really good practice for us to refresh our brains on fractions. One more, Example 98.3. Here we go. Smaller, fraction, larger. Probably I should have skipped a space because these numbers are all fractions, so it would benefit me, but that's okay. The fraction, find the number that is 2/3 of the way from, and now it gives me, I'm going to write these down. I would not expect you to write these down. 2 1/4 to 3 5/6. Mixed numbers, no thanks. We're automatically going to convert fractions, and if I were you, I wouldn't even write down the mixed number. I just convert it in my head as I copied it out of the book. 2 times 4 is 8, plus 1 is 9/4. The denominator stays the same. 6 times 3 is 18, plus 5 is 23/6. Denominator stays the same. John does not convert to improper fractions. He leaves these numbers as mixed numbers when he plugs them in. I think it is a flaw in his character. I don't recommend. Smaller plus fraction times larger minus smaller. There's our equation again, just so we have it in front of us. And let's start over here. Again, all my numbers are positive, so I'm not going to worry about buckets. If any of these numbers came up negative, I would use buckets for this because we have a subtraction in the formula. The smaller number is 9/4 plus the fraction 2/3 times the larger minus the smaller. And if you look in the book, I'm going to show you this so you see. Here's where John has the same calculation. And it's hard to see both at the same time. But he just slapped the mixed numbers into the equation. Ugh, I cannot. So impure. Sorry, John. Okay, we have the same scenario as we did before. We've got a lot of different denominators. Focus on what's in here and deal with that one step at a time instead of trying to fix everybody at once, because we might not need that. Okay, 6 and 4 both go into 12, right? That's the least common multiple of 6 and 4. This will have to multiply by 2/2. This will multiply by 3/3. Okay? 23 times 2 is 46/12 minus 9 times 3 is 27/12. And that's just that part. I'm not worried about this. 46 minus 27 would be 19? Yes, 19/12. Okay, now the parentheses have been reduced to a single number. Now we want to multiply. I'll just copy it all down. Now we multiply. This is 9/4 still, plus 2 times 19 is 38. 3 times 12 is 36. Okay, looking better so far, right? We multiply this by 9/9, right? And that will give us 81/36 plus 38/36 equals, let's just do this little addition over here to the side. 119/36. I'm pretty sure 119 is it prime? No, it's not prime. This is 70 plus 49, and that is 7 times 10, 7 times 7, 7 times 10 times 7 times 7. So that's the prime factorization of this. The 10 I could break down farther, but I know that my this doesn't reduce. Don't pay attention to that. This is the final answer. That's all John wants from us. All right? So if you get your answer and you can see that John has reduced your answer further, go ahead and reduce it. If you're already to the place that he calls the right answer, you're good to go. All right? This is the right answer. This is the formula. I'll puffy cloud of knowledge it one more time. And that is lesson 98. See you in 99.